Rescue Education, we help you to learn faster, easier, and better. I'm Dr. Christine Brzezowski, and I'm going to help you learn organic chemistry. Today, we'll talk about the nomenclature of alkanes and cycloalkanes. This video exactly follows my help book. My book also contains extra test your knowledge problems and complete solutions. Here are the pages to find everything. The entire basis of the nomenclature of organic compounds is that of the alkanes. So we have to talk about the alkane nomenclature first. This is the molecule limonene. It's the fragrant component of citrus fruits such as limes, lemons, oranges, and it's a descriptive name. But there are many hundreds of compounds in citrus fruit, and this is one of them. It would be impossible to come up with a unique descriptive name for every organic compound. So, an organization called the International Union of Pure and Applied Chemistry took on the task of formulating a systematic approach to nomenclature, in which you had one unambiguous name per structure and one structure per name. And then what the systematic actually means is that you can look at the name and literally draw the structure without having to memorize the structure. Before we actually do the rules of alkane nomenclature, there are two things that you're going to need to know. One is the name of the straight chain isomers of each alkane. Methane, hethane, propane, and butane you're just going to have to memorize. Pent, though, pentane, C5, makes sense. Hex is C6, hept is C7, and so on. Most professors have you go and memorize up to decane, and that's usually good. Ask your professor. I do want to point out, though, that by the time you get to the C30 alkane, there are over 4 billion isomers, and the IUPAC nomenclature will let you name every single one unambiguously, so it's amazing. The next thing I want to talk about just for a moment is that we're going to be using bond line formulas because it takes too long to put in every single carbon and hydrogen. So for instance, for propane, the bond line formula is a zigzag. This zigzag, butane is this one, and pentane is this compound. So we're going to be using bond line formulas because it's just a lot easier. The next thing you need to know before we look at the rules are the names of the simple alkyl groups. The way you derive an alkyl group is, for instance, in methane, you take off the hydrogen formally, and you get the methyl group, which is Me for short. Ethane, we do the same thing, remove any of the hydrogens, and you get the ethyl group. Propane's a little bit different because there are two different types of hydrogens. If you remove the primary hydrogen, you get the long chain propyl group. If you remove the secondary hydrogen, you get the isopropyl group, and these both have short forms, PR and IPR, that you can use when drawing structures. Butane is the tricky one because you have 4 different butane isomers, and we can derive them and not just simply memorize them. So if you take regular butane and remove the primary hydrogen formally, you get the butyl group. If you remove the unique secondary hydrogen, you get the sec-butyl group, and you can call it S-butyl for short. To derive the last 2 butyl groups, you use the isobutane isomer. If you remove any of the primary hydrogens, you get the isobutyl group. And if you remove this singular tertiary hydrogen, you get the tert-butyl group, which for short we usually call T-butyl. Finally, we can talk about the alkane nomenclature rules themselves. And of course, we're talking about the IUPAC rules. The first thing you need to consider when naming an alkane is to find the longest chain. Often it's from left to right, but sometimes it is not. And this longest chain is the parent chain. In this particular molecule, I think you can see that the parent chain snakes from the top left to the bottom right. And here is the parent chain. It is 9 carbons long, so that means this is a nonane. And the parent name always goes at the end of the entire name. So this is a nonane. That is our parent. Then the next thing you have to do is look and find the alkyl substituents that are connected or branched onto the parent chain. And what we'll do is we'll always circle them. So these are both methyl groups. And if necessary, we go to rule 3. If you have two methyls, you call that a dimethyl nonane. So let's go ahead and put this in, dimethyl nonane. The final thing we need to do, though, is to number where are the methyls, because there's a lot of places they could be. We have to number them unambiguously. And what I suggest, at least when you're starting nomenclature, is to always number the parent chain in each direction. And then compare the two numbering schemes. So the top numbering scheme, the methyls are at the 3,6 position. If we go in the bottom numbering scheme, they're at the 4,7 position. So what we do is we then have to invoke these rules. We have two substituents. So we look at the lowest number at the first point of difference. Look at both numbering schemes and find the first number where they differ. So it's called the first point of difference. 3 beats 4. So right at the first number, there's a difference. That means that 3,6 beats 4,7, and this is a 3,6 dimethyl nonane. Pause and try these problems, then we'll solve them together. So the first problem, what we do is we have to identify the parent chain first. And again, this one does not go horizontally. The longest chain, or the parent chain, is this one here. It has 7 carbons, so this is a heptane. And again, the parent name goes at the end. So let's write down heptane. Then we'll circle our substituents. Again, we have 2 methyls. So this is a dimethyl heptane. And our last task is to figure out where those methyls are so that we get the exact compound we need. And I think you can see that we don't need to go in both directions, that it's better to put the methyls at the 3 position closer to this end. So this is a 3,3 dimethyl heptane. In the next problem, the longest chain is in fact horizontal. So let's just go from left to right as we normally do. This is again a heptane, so let's put our parent name down. In this case, we have 3 methyl groups. So let's circle them so we can keep track of them. So this is a trimethyl heptane. The big question here is, what is the numbering? In this case, I suggest that you number in both directions and compare the numbering schemes. So along the top, this is a 2, 5, 6 trimethyl. Along the bottom, it's a 2, 3, 6 trimethyl. 2 and 2 are the same, so we cannot decide on that number. We have to go to the 5 versus 3. 3 beats 5, it's the first point of difference. Therefore, the correct numbering scheme is 2, 3, 6. So this is a 2, 3, 6 trimethyl heptane. Now, we've just been dealing with methyl substituents so far, but there's a lot of other substituents that you'll run into. And we have to address the problem of alphabetical order of substituents. We need to know which prefixes are included in the alphabetical order and which are not. So included in the alphabetical order is the I of iso, the N of neo, and the C of cyclo. Not included are the D of di, the T of tri, the T of tert, and the S of sec. So as we look at comparing these alkyl substituents, ethyl comes before methyl because E comes before M. Sec-butyl comes before methyl because we don't count the sec, the B comes before the M. And cyclopropyl, the C is counted and it comes before the P of propyl. The most difficult rule we're going to look at is if there are two or more possible parents in a compound. In other words, you find two chains that are the same length, which do you pick? And the rule always is that you pick the parent chain that has the most branches. That one wins, because the more branches you have, the simpler those branches are to name. Let's talk about common names. In all of the nomenclature that we will be looking at, there will be very simple compounds that have common names that are very, very old names that are also incorporated into IUPAC. So those you will need to know, or at least check with your professor if they want you to know these. So this compound here, this is called isobutane, and it's referred to exclusively as isobutane. This is neopentane, and this is isopentane. So they're not referred to by their IUPAC names, they're referred to by their common names, and we put a little star besides the common names that are important to know. Pause and try these problems, then we'll solve them together. B is particularly tricky, so be careful about it. Okay, the top structure, we need to find the parent first, as we always do, and the parent snakes through like this. So the parent has 10 carbons, so this is a decane. So let's put this way over here. This is a decane parent. Next, we do, as we always do, we circle the substituents. So we have a ethyl, we have an isopropyl, and we have a methyl substituent. So we need to put those three substituents in alphabetical order. The last in alphabetical order is the methyl. So we run the name of the methyl right into the name of decane. We leave a little space for where is that methyl. Then isopropyl goes in the middle. Leave a little space for the number. And ethyl goes first. So E of ethyl beats I of isopropyl beats M of methyl. Last thing we need to do is say, where are those alkyl substituents? So we've numbered in one direction, and I recommend you, at least at this point, still number in the other direction. So the two numbering schemes, if we take the bottom numbering scheme, we're looking at 4, 6, 9. So 4, 6, 9. Versus if we go in the other direction, we have a 2, 5, 7. And we look at the first point of difference, which in this case actually happens to be the very first number. 2 beats 4. So this is a 2, 5, 7. The methyl comes at 2. The isopropyl comes at 5. And the ethyl comes at 7. So we have two of the same structure. That's because this problem is dealing with our hardest rule, which what happens when you have more than two parents. And in fact, this molecule has 3 parents. The correct parent snakes through the molecule like this. Okay, and we'll talk about why that is the correct parent. But you can see another parent that goes horizontally that also has 7 carbons. So these are both heptanes, and maybe you found the other one too, the third parent. How do we figure out which one is the correct one to name? In the molecule on the left, we have 1, 2, 3, 4 substituents. In the molecule on the right, we have 1, 2, 3 substituents. So 4 substituents beats 3 substituents. And this is not the correct parent. This molecule is the correct parent. So let's go ahead and name it. So this is a heptane. parent. We have a propyl group, and we have 3 methyl groups, so that's a trimethyl. So the propyl, starting with a P, it has lowest alphabetical priority, so we're going to run its name right into the name heptane. So this is a propyl heptane. Leave a little bit of space for the numbering, and this is a trimethyl propyl heptane. So what are the numbers? In this case, I do recommend we go in the opposite direction too and compare the 2 numbering schemes. So the top numbering scheme, we have 3, 4, 5, 6. So 3, 4, 5, 6 versus 2, 3, 4, 5. 2, 3, 4, 5. So at the first number, we already have a point of difference. 2 beats 3. So the correct numbering scheme is 2, 3, 4, 5. So the methyls are at 2, 3, 5. And the propyl group is at 4. So this is a 2,3,5 trimethyl 4-propyl heptane. Okay, the last thing we need to do in this section is talk about cycloalkanes and look at their IUPAC nomenclature. If you have a cyclic alkane, you add the prefix cyclo to the corresponding alkane. So we just say this molecule with 4 carbons is cyclobutane. There will be substituents on many of these cycloalkanes, so how do we deal with the numbering? If you have 1 substituent, it's not necessary to number it. It's assumed to be at position 1. If you have 2 substituents, number 1 position goes to the substituent with alphabetical priority. If you have 3 or more substituents, we again revert to the rule of the lowest number at the first point of difference. We look at the 2 numbering schemes and then compare until you reach the point of difference. If the ring is small or smaller than the alkane chain that it's connected to, then the ring becomes the substituent. Pause and try these problems, then we'll solve them together. Okay, let's solve these problems. The first one's fairly easy. The ring has 6 carbons, so this is a cyclohexane. And it has a single substituent, which is an ethyl. So this is an ethyl cyclohexane. No need to number where the ethyl is because it is assumed to be at position 1. The second problem has a 5-membered ring. And so it is a cyclopentane. It has 2 substituents. It has a methyl, and it has a sec-butyl substituent. So this methyl goes second in alphabetical priority. The sec-butyl goes first. So we say this is a methyl pentane. Leave a little space for the numbering. And then this is a sec-butyl. B goes before M. So the last thing we need to do is address the numbering. I hope you can see that you have to number around the outside on the right. Numbering on the left would be 2 high numbers. So in either case, the 2 best numbering schemes are 1, 3. So we can't decide based on those numbering schemes. The rule then is, when the 2 numbering schemes are the same, is you give the substituent with alphabetical priority the lowest number. So this is a 1 sec-butyl 3-methyl cyclopentane. The next compound is also a cyclohexane. What are the substituents? We have a methyl, we have an ethyl, and we have an isopropyl. So let's put in our substituents in the correct order. The methyl goes last. Its name comes right before the cyclohexane name. Leave a little space for the numbering. Then we have isopropyl in the middle. And at the front, we have an ethyl group. So this is an ethyl isopropyl methyl cyclohexane. What is the numbering scheme? I hope you can see that you should go around the right for the two numbering schemes, 1, 2, 3, 4. So this is, if we go around the outside and start at the top, this is a 1, 2, 4. If we start at the bottom, this is a 1, 3, 4. So the first number, 1 in both cases, 2 beats 3. So the correct numbering scheme is a 1, 2, 4. The methyl occurs at position 1. The ethyl occurs at position 2. I'll just fit this in. And the isopropyl is at position 4. So this is a 2-ethyl, 4-isopropyl, 1-methyl cyclohexane. And the final rule we'll cover with this last example, and that is that the cyclopropyl group is actually smaller than the 4 carbons of the chain it's attached to, so it becomes an alkyl substituent, a cycloalkyl substituent. So this is a, and I'm not even going to number this, a 2-cyclopropyl butane. If you found this video useful, you'll love my new organic chemistry help book. It takes the essential topics of first semester organic chemistry, puts them into discrete units with concise and crystal clear explanations and many sample problems. But the best thing of all is it has test your knowledge problems. So extra problems that help solidify your knowledge, and all the solutions are included at the back of the book. If you're interested in my book, go to my website, rescueedu.com.